Hello, welcome back again to Statistics and Mathematics Tutor channel. In our previous video, we learned quite a lot on introduction to normal distribution. So today, we are going to start our studies on standard normal distribution. Standard normal distribution is basically used to calculate for the probabilities of normal random variable. For example, to compute the probability that our x is greater than a for a normal distribution, you have to just state our f of s as we learned in our previous video for the PDF for the distribution, as you can see it here. So we are just going to integrate the PDF on the interval given, and you will see that integration this function is quite cumbersome, right? So we have to standardize our x so that it will enable us to find for the probabilities of the normal distribution. And they just bring in memory standard normal distribution. And we are trying to say that the standard normal distribution is used to calculate for the probabilities of normal distribution. And for us to be able to calculate for the probability of the normal distribution, we use what we call the z-score. And here our z, which is the z-score, is equal to x minus mu divided by sigma. So for this z-score, we are saying that our z follows what? A normal distribution with a mu 0 and then variance of what? 1. That's what our standard so for standard normal distribution, we are just saying that for standard normal distribution is going to have a mean of what? 0 and then variance of what? 1. So since we had PDF for normal distribution, standard normal distribution also has what? A PDF. And since when we want to standardize, we are just saying that our z is equal to x minus mu divided by sigma, right? So we are just going to come here, x minus mu divided by what? Sigma, as you can see here. So we are just going to replace this one by what? Our z, right? To be the PDF for the standard normal distribution. So f of z is equal to 1 divided by square root of 2 pi sigma times e raised to the power negative half z raised to the power square. So this is the PDF for standard normal distribution, right? So the PDF for the standard normal distribution is different from, it's more or less different from the PDF for they are almost all the same, right? But just by we are using the z, right, to standard our x to enable us to find for our probabilities of x. That's the reason why that PDF will change into this, right? We are just saying that our z just lies between negative infinity to a positive infinity, right? So before we will continue solving some examples on standard normal distribution, I want us to go through this example. We are having an example here. In our basic schools, we are just saying that 1.5 plus 0.09. When we add these two, we are going to get 1.59. What about when we have 1.4 plus 0.01? Once we add these two, you are going to get 1.41. So this is just telling us something small. This is just telling us something small that in addition, so in addition, as I just said, if you have something like, let's say if you have something like 1.61, it means that you can just express it in addition term to be 1.6 plus 0.01, right? 1. So once we add this, we are going to get the same thing as 1.61, right? So we are having this. So we will be meeting these decimals a lot. Basically in 2 decimal place a lot in our calculations. So please kindly make sure you familiarize yourself with these decimals, how we can add them, so that when you get there, things will be very, very smooth for you. But before we will solve examples, I would like to show you the standard normal distribution table. We are having what we call standard normal distribution table. This standard normal distribution table is being grouped into 2. We have what we call the positive standard normal distribution table and the negative standard normal distribution table. So let's kind of visit the table and let me differentiate how the table is, so that when you get a question and then they want you to calculate for the probabilities, you can easily do that. So let's go to our table. So this is a typical example of negative standard normal distribution table. It's a negative standard normal distribution table because we are having our z here, right? And then you see that the entries for all the z's that you can see, they are all positive. Negative 3.4, negative 3.3, negative 3.2. This z is just telling us that there is what? A negative standard normal distribution table. And moving from the 0.01 at the top here, 0.01 at the top there, 0.02 at the top there. All the probability entries that you can see here are the probabilities for the negative z-score, right? So these are the probabilities, right? And I'll show you how you get your probability when you get your final z-score answer. And then we have what you call the positive standard normal distribution table. It's positive because when we see the entry for the z, you see we're having positive 0.01, positive 0.2, positive 0.3, positive 0.4, positive 2.8, and the rest. And these are the probabilities, how you get the probabilities. So when you are solving examples, I'll walk you through. So this is typically how the table for the normal distribution look like. So let's go to our worksheet to start solving examples. So here, our first question is, he said we should find the probability from the normal table, right? So our question 1, he said that find the probability that our z is equal to 1.59, right? We should find just our probability that our z is equal to 1.59. So this is just telling us that the z-score, which is equal to x minus mu divided by sigma, has been already been what? Calculated, right? You have been able to calculate what? This one, and he has given us the final answer to what? 1.59, right? And then he just wants us to find the probabilities for what? The z. And mind you, this 1.59 is not what? A probability. We know that probability lies between what? 0 and then 1. So we have to just use our standard normal table to find our probability for the 1.59. So when you have a question like this, you just probability that our z is equal to 1.59 can be written as phi of 1.59, right? So you just take the number, group the number into 2. The first 2 digits that you will see will be, you will check it from the row and then map that one to the next number that you see on the column, right? So that's the reason I have grouped it into 2. So 1.5 will go for the row, and then 0.09 as we did the addition at the top there, right? 0.09 will go for what? The column. So let's visit our normal distribution table to be able to find our probability for 1.59. So since our z was positive, right, we were having z to be equal to 1.59, we are going to the positive z table, the place where the entry for the z are all positive, right? So when we come here, we can just locate our 1.5 at the row section. As I told you, the 1.59 can be grouped into 2. The first part will be 1.5 for the row, and the second part will be 0.09 for the what? The column, right? So 1.5 here at the row section. So you have to also locate 0.09, which is here, right? So you are going to trace the 2 where they meet, right? So you just trace this one down to where it will meet 1.5, right? And then just trace this one too. And then you can see that they are meeting at 0.9441, right? That is where the 1.59 you will get it from what? The table. So you just group it into 2. The first 2 digits you will pick it from the row section, and then the last digit, that's the 0.09, you will pick it at what? The column section. They just trace where these 2 numbers meet. That place will be for what? Our probability. So here we are having our probability to be, we are having our probability to be 0.9441. So that's how you can read from what? The normal distribution table. Our next question has been given as this. We should find the probability that our z is less than negative 1.49. So typically you can see that this our z, right? This question can be written as phi into bracket negative 1.42. Right, and then you can see clearly that this is having a negative, our z here is what? Negative. So here we are going to straight toward the negative negative standard normal distribution table to calculate for what? Our probability. But first you have to group this a number into 2. We are having negative 1.42. So our row, we are just going to locate negative 1.4 on the row section, and then locate 0.02 at the what? Column section to calculate for what? Our probability. So let's visit our table. So when you come here, you are just going to locate negative 1.4, right? We are going to the negative table since our z there was what? Negative. So here we are just locating negative 1.4 on the row section, and then just go and locate 0.02 at the column section, and then just trace it down where it's going to meet 1.4. Sorry, yeah, negative 1.4, and then trace it here. And we see that our probability is what? 0.0778, as you can see clearly here, right? So this is our probability when you calculated from what? The tables. You will be having 0.0778. The next question is, we should find probability that our z is greater than 0.09. The probability that our z is greater than 0.09 can also be written as 1 minus probability that our z is less than 0.09. Less than or equal to 0.09. Right? This is, we are just calculating that our z is greater than 0.09. It means that we are going to calculate up to what? Infinity. Since we are not having limits that will handle the greater than, we have to change it to less than. And then once you subtract this one from 1, we are going to get the probability that our z is greater than 0.09. And then we know that the probability that our z is less than or equal to 0.09 can be written as 1 minus phi of 0.09. So just find the phi of 0.09 from what? The table. And then 0.09, as you can see here, can be grouped into two. The first row, the row will take the first two digits, that's 0.10. And the column will take the last digit, that's 0.09. So you are just going to the table and then just locate where the 0.0 and the 0.09 will meet on the table. And then just get our probability, subtract it from 1, and then get our final answer. So let's go to the table. So when we come to the table, we all know from the question that we're having what? A positive z here. So we are going to straight to the positive distribution table, right? So we come down here. And the positive z table, we are locating 0.0 at the row section. And then we are going to locate 0.09 at the column section. We are just going to trace. And then trace this one here. Right? They are meeting at 0.5359. We are going to subtract the 0.5359. Right? You are just going to subtract from 1. And once you subtract, I get it 0.4641. So this is how you get the probability for z greater than 0.09. That's the probability, right? So what about when you are given that we should find the probability that our s lies between negative 2.5 and then 2.50, negative 1.25 and then 2.50. Sorry. Probability that our z lies between negative 2.5 and then 2.50. I'm making this same mistake. I'm very sorry. I'm at the middle of the video. Negative 1.25 and then 2.5. Right? So at the end of the day, when you have this thing, a is less than z, less than or equal to, let's say, b. Sorry. So we are just going to calculate for the probability for this one. So the probability for we know that a is definitely less than what? B. Right? And since they are in between, you are just going to subtract. So since this b is greater, you are going to get phi of what? B minus phi of what? A. Right? So that's what you are going to do for this one. So you are going to calculate the probability for this one and then calculate the probability for this one, and once we are done, we are just going to subtract. Right? So you are going to find phi probability for 2.50 and then subtract it for probability from negative 1.25. Right? So since you have been able to, appreciate how you can locate it from the graph, let's do it straight away. Once you find for the probability that our z is equal to 2.50 from the normal distribution table, positive normal distribution table, we are going to get 0.9938. And then if you find for the probability that our z is equal to negative 1.25, we are going to get the probability to be 0.1059. So once you subtract this from this, you are going to get 0.8882. So this is how we are going to find our probabilities for the standard, our probability for the normal distribution when we are being asked to do so. So what about when our z score is given? When we are to find our z score, when the probability is being given to us. So sometimes, for this question, our z score was given to us, right? You could see that our z score was given to us in this question, and then we have been asked to find for the probabilities. So what about if our z score was not given and the probability is given to us, and they have been asked to find for the z-score. How are we going to go about it? So we are going to start on those questions. So here our first question is, find the z-score corresponding to the 95th percentile. So here we have been asked to find for what? Our z-score. And here our z-score will be probability that our z is equal to, let's say, A. The A there is what the final answer for our z calculated, right? Which will be equal to 0.95. That's the probability. So here we have been given the probability and we have been asked to find for our A, right? And know that this probability that our z is equal to A can be written as phi of what? A, which is equal to 0.95, right? So we are supposed to find our A, that's the z-score value, right? We have to make what z the subject. If you want to make the z the subject, our z will be equal to negative phi of what? 0.95, right? As when you divide here, we divide here by phi, divide here by what? Phi. And when the phi move up, it will be negative phi into bracket of 0.95. So here we have to find this one from the z table. But right now you see that the z-score is not given to one, but rather the probabilities. We are going to look through the probabilities to get what? Our z-score, right? So let's go straight to our table to find that. So this is our z table, positive z table. So this is our positive z table. So when you come, you are not going to locate the row and a column to get the probability. Right now here the probability is given to us. So you are just going to locate where the probability, that's 0.950 lies, so that we can just trace it to the row side, trace it to the column side to get what? Our z, the value for what? The z, right? So when you come here, you just have to just check where you will locate 0.95. But when you come here, this row contains 0.5, 0.5. So you just move along and then see where we are starting from 0.9. So once you see where we are starting from 0.9, you take your time to locate where we can see 0.95. And then you can see that we have 0.945, 0.9463, 0.474, 0.9484, 0.9495, and 0.9505. So you can see that here is 0.9505, and then here is 0.945. So this means that we are not having exactly 0.950, right? So it means that our 0.950 lies between what? 0.9495 and then 0.9505. So this just lies between this one. So since this lies between this one, we just have to maneuver our way through so that we are going to get our z-score, right? So we are just going to trace where you can locate the probability to the row side, and when you come to the row, we are getting what we call 1.6, right? 1.6, and then locate where we can locate, and then just trace where we can locate our probability to the column side. Here it's just lying between 0.945 and a 0.950. So we are just going to trace this one to the top, to the column section, right? So once you trace it to the column section, we are going to have here is 0.01, 0.0, 0.01, 0.00, 0. So you are just going to have 0.04 and a 0.05 at the column section, right? So here, this is what you are going to have: 0.04 and a 0.05. So here we are just going to add the rows to what? The column, to get what? Our z-score. But you can see that for the z-score, for the column section, we are having two digits. Since we are having two individuals here, we are just going to add the column, the row. So here will be 1.6 plus 0.04 plus 0.05 divided by our 2, right? We are just going to find our mean of the 0.04 and the 0.05, and then add it to 1.6, which is the row, to get our our z-score, right? So here, when we add these two, we are going to get 0.09 divided by 2 will give us 0.045, right? So we are going to add, let me open a new worksheet so that you understand what I mean. So here will be 1.6 plus 0.04 plus 0.09 divided by 2. Since the 0.95 was lying between 0.04 and then 0.09, we just have to find the midpoint between this one and then just add it to the row side. So here will be 1.6 plus 0.09 divided by 2. I'm going to have 1.6 plus 0.045, and then when we add these two, we are getting 1.645. so this will be our z-score, right? This will be our z-score for the question that was given to us to calculate. So when you go to our worksheet, we are getting the same answer here. Let's continue. Our next question was given us, we should find the probability that our z is less than alpha or a, which is equal to 0.800, right? So for here is the same thing. I'm still going to get phi of a, which is equal to 0.80, right? So since we have this one, I just want to find our a, which is the z-score, to be phi inverse of 0.800. So I'm going to locate this one from our normal table. So let's visit our normal distribution table, the positive one. So once we visit that, we are just going to locate where we could see 0.800, right? So we come to the positive z table and then we will start locating. So always don't start from the 0.0, the z for 0.0 to be 5, 6, blah blah. Just trace where the 8 starts from, right? We could see it clearly that our 0.8 is starting from here, right? And then we have been asked to locate the probability that our z lies, probably that you have been given that our probability was 0.800, and then we should just locate where 0.800 is on our distribution table, right? But when you come here, you could see it clearly here that here to our z, our probability is also lying between 0.7995 and the 0.8023. We are not having the exact 0.800 from the table, right? So here we are just going to trace to the row side, right, to get 0.8, right, and then add the column section. So the column section to still we are getting this one, right? We are getting this one 0.04 and then 0.05. So here we are going to add this one. So we are going to get 0.04 plus 0.05 divided by 2, right? And then we are going to get 0.845, right? So this will be what our z-score for the probability that our probability for 0.800, right? So let's go to our next question. Right? So sometimes you will be asked to also find how we will be asked to also locate how we can find our z subscript alpha, right? How we can find our z subscript alpha, right? Sometimes our z will be given to us with some subscript alpha, and then we will be asked to find that z2, right? So how are you going to do it? I'm going to walk you guys through that one too. So let's go to the first question. So 1, our z subscript 0.05, right? So I have been given this one, I have been asked to solve for z subscript 0.05, right? So right now our concentration is supposed to be on the subscript, right? So most of the time we just let our subscript represent what? Alpha, which is 0.05, and this 0.05 is just telling us that the z that we want to find is on a negative table, right? Negative, and then you just have to subtract 1 from it to come to the positive section. I just want us to calculate our z from what? The positive one section. We are having our alpha to be 0.05, right? So you just subtract 1 from it, as I have done here, to get 0.95. So more or less, if you get 0.95, this is what? A probability, right? So this is the probability given to you. So you are just going straight to the normal distribution table to locate where 0.059 is, right? And for this one, we have already done it, where we are given probability that our z is equal to alpha, and then that probability was given as 0.95, and then we just calculated for our alpha, and of which we get 1.645 just now, right? So you could see that the alpha here, once you subtract 1 from it, you are going to get 0.95, and this 0.95 is the probability. You are just going straight to the table and then locate where the probability is, just trace to the row. So here the row section is 1.6, and then the column section, since it's lying between 0.04 plus 0.05, right? Just find the midpoint and just add it to 1.6, right? So we have just done this one now, right? So we just add it and just get 1.645, right? So our, from the normal distribution table, our z subscript 0.05 is equal to 1.645, right? And then our z subscript, we have been asked to also find our z subscript 0.01. So our z subscript 0.01, we are having 1 minus 0.01, right? So you're just going to subtract 1 from this, so I'm getting 0.99. Once you get 0.99, just go straight to the normal distribution table. So when you come here, you are just going to locate where we get 0.99, right? So for 0.990, we are just going to locate where we will get that one. So when we come at the top here, right? When we come at the top here, we will see that we have 0.9901, but we are supposed to get 0.990. So it means that the 0.9 lies here. It's just lying here, 0.9898, and then 0.9901. It's just lying here. It's just lying in between this one. They just trace to the row, and then just trace to the column, and then find the midpoint of the column, and then just divide it by 2, right? And then add it to 2.3. So that is what we have done here, right? That is what we have done here. So we'll be getting 2.3 plus 0.02 plus 0.03 divided by 2, right? And then we are going to get 2.3 plus 0.025. Just add it together and we are getting 2.325, right? So let me add one more question to it, right? So what about if you are asked, right? For example, let's say we have been asked to find the probability that our z is equal to alpha, where the main probability is 0.9898, right? So here we know that this one can be written as phi of alpha, which is equal to 0.9898, and our alpha is equal to phi inverse of 0.9898, right? So we have this one. We are just going to look for our z from the normal distribution table. So let's visit our normal distribution table. So when we come here, we are just going straight to the positive table and locate where 0.9898 is. And you can see it clearly that 0.9898 is this one, right? So you just trace to the row and trace to the column and then just add to get our z. So here, since it's not lying between any two interval, we are just going to add them straight away. So here you are going to have 2.3 plus 0.02, right? So when you trace this one to the top, you are going to get 0.02, right? So when you add the two, you are going to get 2.32, right? But when it lies between the two, you are going to find the midpoint. But when it lies, it falls on a particular probability there, you are just going to trace to the top, down, and then just add. So thank you for watching Statistics and Mathematics YouTube channel. So please, if you haven't subscribed, kindly make sure you subscribe to Statistics and Mathematics YouTube channel so that you will learn a lot. Now, next video, I'm going to solve more questions on applications of standard normal distribution. So make sure you watch that video. Thank you. Bye.